Videos to allow you to correct your homework for section 4.2.4. I wanted to start by looking at the methods and meanings. They remind you that a ratio or a rate is a ratio that compares the amount one quantity changes as another quantity changes. So rate is the change in one quantity over the change in another quantity. A unit rate is a rate that compares the change in one quantity to one unit change in another quantity. So in other words, a unit rate would be like miles per hour, because we're talking about how many miles in 1 hour. It could also be miles per gallon, how many miles your car can go in 1 gallon of gas, or the cost of 1 pound of chicken, or anything like that. That would be unit rates. So they want to know if the relationship shown here is proportional. If so, complete the proportions web. If not, why not? So, a couple things again we want to remember when we think about whether a situation is proportional or not. Is there a constant multiplier from one to the other, from the x value to the y value? And we can see that there is. You're multiplying by 2.2 each time. Another thing is, will it go through 0, 0? In other words, if they work 0 hours, will there be 0 cubic yards of dirt excavated? And that is also true. So we would say, yes, it's proportional, and then we need to complete the proportions web. So first thing we need to do for proportions web is to look at these different areas. One is, what is the amount? What is the unit rate? Well, we can see since the multiplier is 2.2, unit would say how much dirt are they excavating in 1 hour? Because again, unit means how much in one. So 2.2 yards of dirt are excavated each hour. Then another thing they're asking for in a proportions web is, what is the constant proportionality? The constant proportionality is just that multiplier. It's that 2.2. Then we would want to create an equation. So they're saying, let's let H stand for hours, and they should have indicated that. And then let D equal amount of dirt excavated. And then that would be in cubic yards. And so then the equation would be that the amount of dirt excavated will always equal that constant of proportionality, 2.2, times however many hours. So in other words, that's what's happening. We're always multiplying the hours times 2.2 to get the amount of dirt excavated. So that's how our equation is created. Then we want to make a basic table. Now, for your table, they are using H for hours work, D for amount of dirt excavated, and they've already given us some values in a table. But additional ones that they added to it would be 0, 0, because again, 0 hours work means you would have excavated 0 cubic yards of dirt. 1 hour work would have meant that you excavated 2.2 cubic yards of dirt. And then lastly, a graph. Now, their graph is really simplistic. It should be more than this. First of all, it should have a title. Secondly, it should have labels. So, like this would be hours worked. This would be amount of dirt excavated in cubic yards. And then, really, it probably should be done on graph paper. So, what they're doing is they're graphing points from their table, but you could again always graph points from this table as well. So 0, 0 is right here in the corner. And then they went over 1 and up 2.2 and put the second point, and then they connected. Now remember, if you're deciding if the graph should be connected or not, the question is, can both hours worked and amount of dirt being excavated be represented as a decimal or as a fraction or mixed number? And the answer is yes. If that's the case, if it can be that both parts can be written as a decimal or fraction or mixed number, then we would connect the line. If not, we would not. So if you had something like number of bikes sold, that is not something that you're going to be able to have a partial bike, so we would not connect the dots. But again, I would say that this should be a little more detailed, and the graph should definitely be more detailed. Here, in a recent small race, the winning snail traveled 5 and 8,500 centimeters in 3/4 of a minute. How fast was it traveling in centimeters per second? So what we have is centimeters per portion of a minute, but they want it in seconds. So the first thing we would do is say, all right, 3/4 of a minute would be the same as 3/4 times 60 seconds in a minute. That would give us 45 seconds. So if it can travel 5 and 8,500 centimeters in 45 seconds, how far can it travel in 1 second? So we'd take 5 and 8,500 centimeters, we would divide it by 45 seconds, because again, we want to know how far can it travel in 1 second, per second, it says. And you would get 1,300 centimeters per second. Here they want the area and perimeter. This is a trapezoid on its side. So we can see that the base 1 and base 2 are going to be 7 feet. And then this one would be 3 plus 7, or 10 feet. So for your formula, you're going to use base 1 plus base 2, get that answer, then divide by 2, then multiply by the perpendicular height, which is here or here, 7 feet. So again, I should see the work. Just having the answer here would not be adequate. You should show me that you put it into the formula for area of a trapezoid. Base 1 plus base 2, get that answer, then divide by 2, then multiply by perpendicular height. For perimeter, I should also see what did you add up. That you took the 7.6, let me try to get a different color so it stands out better. 7.6 plus 7 plus 7 plus 7 plus 3 to get the perimeter. Now, you could have also found the area of this by looking at it as a square with a triangle, and that's fine too. But again, you should get the same answer, and I should see the work. Here, they want you to circle the terms and then simplify. So remember, terms are always separated by addition or subtraction. So those would be the 3 terms. And then we would say 1 times 4 is 4, 3 plus 4 is 7, 7 plus negative 7 is 0. Again, you should have more work than what we have here. This would be a term, this would be a term, this would be a term. So 3 times negative 10 is negative 30, 2 times negative 20 is negative 40. So we have 50 plus negative 30 plus negative 40, giving us negative 20. But again, show a little extra work. Show that extra step in between. Here, multiplying this, negative 50 times 2 is negative 100, plus 4 is negative 96. And here, oh, and by the way, I should have circled this as a term. Here, we basically are going to take 4 plus negative 170, which is negative 166. 5 plus negative 4 is just 1. So negative 166 times 1 is negative 166. Here they're saying that he set up these 4 tight ropes into this rectangle. And if he starts at point A and travels completely around the rectangle, how far does he travel? In other words, what is the perimeter? So 12 plus 15 plus 12 plus 15 is what I should see, giving us an answer of 54. How can we represent his distance by an expression? We could think of it as 2 times 15 plus 2 times 12, because it's a rectangle. Or you could simply write 12 plus 15 plus 12 plus 15. Here they want to know if these represent a proportional relationship and how can you tell. Again, for a proportional relationship, it has to show that it would go through 0, 0, and also that there's a constant multiplier. So what you're going to find for proportional relationship is it always should be set up as like y equals k times x, where k is just the constant of proportionality. It should not have any addition or subtraction connected to it. So this would not be a proportion. And again, the reasoning is if you put in 0 for x, you're going to get 2 and 3/10 for y. So that's not proportional. Again, it should only contain multiplication. B is proportional, and the constant of proportionality would be 6/13. And C, again, is not proportional. Again, we should only have multiplication, not any addition or subtraction of terms. Here, if a stack of 6 bricks is 2 feet high, how many bricks are in a stack 20 feet high? So again, I should see your work somehow. So maybe you're going to say 6 bricks over 2 feet equals an unknown number of bricks over 20 feet. All right, and again, this isn't the only way to show your work, but you do need to show your work. And so this would be like B for bricks. We don't know how many. You could do cross products, 6 times 20, and then divide by 2. Or you could say 2 times 10 is 20, so 6 times 10 would give us the number of bricks, which is 60. And then here, if you set it up as a proportion, the advantage for this one is now you simply replace the number of bricks with 20 and get rid of my label because this would now be bricks. And then I want to know what is the number of feet. So here you would want to do, pardon me, you would want to do the cross products because there's no nice multiplier to get from 6 to 20. So we would multiply the 2 diagonally that we know, 20 times 2, and then we would divide by the third value, so that x is standing for multiplication, and then we would divide by the 6. So maybe I should have used a different variable here, like f for feet. So multiply the 2 diagonally that you know, divide by the third, and that's how you get that answer, which ends up being 6.6 repeating, which is the same as 6 feet 8 inches. They also talked about the fact that you could estimate it to be this, between 6 and 7 feet. For 467, if she uses a scale factor of 8/5, will the shape she creates be larger or smaller? It will be larger. Whenever the scale factor is greater than 1, it's going to get larger. List 2 different scale factors she could use to make something smaller. Again, don't list any numbers between 0 and 1, but actually come up with some. Maybe 1/3, maybe 2/5, maybe 1/2. 2 different scale factors she could use to make a larger shape. Again, don't put any numbers greater than 1. Give me some values greater than 1. So 1.5 or 3 or 8/5. We already talked about making it larger. Here they want to know, probability-wise, if this is the setup, who has a greater chance of listening to heavy metal album? So if you look at Maud, she has 5 heavy metal albums out of 8 albums. Claude has 7 heavy metal albums, out of 12 albums. So you could divide 5 divided by 8, 7 divided by 12, and see which is greater. You could get a common denominator of 24, but either way you find out that grandma has a greater probability. So again, show your work as to how you knew that Maud's probability was greater than Claude's probability, whether you divided or whether you got a common denominator. Here they're saying you might be amazed to find that at your first job, 1/4 of your paycheck will go to taxes. So if these are the amounts you earn, how much will go to taxes? In other words, what's 1/4 of $84? What's 1/4 of $128 and $210? Remember that if you're talking about money, if your calculator shows 52.5, you have to add that extra 0 because we don't write money as 52.5. We write it as $52.50.